Hi, everybody. So let's get into it. Yeah, so the big thing that with this continuous testing is trying to identify what our challenge is and what we're trying to do with this. And when we make changes, testing the intended changes is usually pretty easy. We know what we changed. It's the unintended changes that usually get us. And they're sometimes hard to see. And they do add up over time for when you finally realize, oh gosh, I've changed my cycle count, or why doesn't this work sound like it used to? Um, you have to do quite a good bit of digging to find out where that could have come from, and it could be multiple things. So we're going to today talk about two types of tests you can integrate into your pipeline. You might put it in your CI, but some of them are really kind of set to really check your check-ins right before you maybe want to push it, because some of them do have a good bit of audio data, or will use this considerable amount of CPU. And that is sonic tests, which is, does my plugin sound like I think it's supposed to sound? And performance tests, which is, am I using any more cycles or more percent of the CPU than I was before I made my change? And today, currently, we probably make our changes, build, and then validate our intended changes. So we're going to try to build in some harnesses that check for unintended changes, and then allow us to update references. So we can, once we decide to accept the change, maybe it's an intended change, it would look like a failure, perhaps, with our tests. We're able to then update our sonics and update our expectations on performance, and then continue to move on. And so hopefully this ends up giving kind of a reliable way for you to continue through your changes. So what are the tools we're going to use today? Number one is DAW Dreamer. It's a Python-based juice DAW, which is, I think, made by, it's open source. It's made by David Brown. And it's basically what we're going to do for all of our offline testing, all of our rendering. There's a tool that I hacked together called Plugin Perf, which is going to test and give us kind of a measurement for our real-time testing. Claude Code, we're going to dig into, and that's going to give us our preset creation and our failure analysis for when we do get failures. And your docs, which is possibly one of the most important parts of this. It's the glue that actually is going to help direct, how we're going to pull together all of the presets and what the intent use of the product is. So today our agenda is going to be, let's make some presets, let's go over the sonic tests, and then performance tests. Context. I use context a lot, so I was like, oh, what does that mean? Context, everything that I have here, I'll post on the Discord. So I'll go over some scripts. You may not be able to see them. And some things, but you'll be able to check everything out. And the application that is very alpha, definitely is available to everybody. They can participate if you want. All right, let's get into presets. Context, this is such an important bit. Context focuses our testing, and this does it for testers that you work with today. The more you're informed in your dev team, the more you inform folks of what you're trying to build, the better you're going to get that. And that focused testing is going to get us better bugs. So I imagine you have these kind of docs if you're building a product, such as a PRD, a marketing brief, even a parameter spec you've put up that shows the ranges, product goals, or even code. Really, whatever you need to kind of start to just set Claude, which is going to be making our presets on the right track, is really important. And you can also use Claude to help flesh that out, and it's kind of a good time to do this in your workflow. So we're going to use a plugin that I'm working on, and basically to show that it has a lot of features that are really good at breaking when you do too many things. So lots of settings, lots of different toggles that will, make different parameters work in different ways. And so the ability to do a full burn through on something like that is actually quite tough. And so we're also with that, we're going to leverage Claude skills. So this is about a month old, I think, for a feature that was added to Claude and Claude Code. And just to give you a heads up on what it is a way to take a bunch of information about a task that you want Claude to be able to do, but not eat up all of your context or your tokens. Usually if you have like a large agent doc, that might eat up half of your bandwidth when you're trying to work with it. This actually adds a bit of the front matter to the top, which gets read in as part of your system prompt. And then when the user asks, hey, I would like something that's inside of that, it then reads out the skill. The skill then directs Claude to different reference files that it can use to complete the task you give it. And so the one that we're going to start off with is the skills file for the Echo Space Preset Designer. And so we start with a front matter YAML kind of saying what we want it to be able to do, how we want it to be able to approach it. And specifically, I want this to be able to handle creative presets, but also diagnostic ones. I have a delay time and the filters change over time. I want to make sure those remain stable and don't change. If I make some change, or LFOs, I want to make sure those are consistently keeping the rates that they're supposed to. These are all things that we want to be able to test out. When I ask it to, hey, please create me some presets for Echo Space for maybe some more clear things about diagnostics or where I think you could fill in some gaps, it'll then trigger, as we said, the preset design expert kind of main part of the markdown. And then it'll trigger out to the references, which I'll show you in a bit. Interesting, almost kind of meta thing is Claude has a skills creator skill, which is actually nice because it helps you kind of flesh things out. So if you are starting with some docs that maybe aren't fully fleshed or have all the info you want, it will actually sit there and interview you and kind of help you get on a good setting to go forward. So let's go over the references that I'm also including in here. So 4 items here. One is some audio hardware analysis. This is a history on the sounds that I want to emulate. I want it to pull out. So things that it should know. If you ever ask Claude or ChatGPT about gear, it thinks it knows, and then it starts to get a little confused and forget this is that. But maybe it's pretty good. This is going to help kind of keep it on track and remind it, like, what are the delay ranges? What are the things that we want to hear or we're trying to get? Param spec. This is a very detailed parameter spec of everything in the plugin. And in addition to this, which I don't know if I would have made by myself, but I was able to have it do matrices of which options turn off which params and turn on parameters, which is super important so it doesn't make a bunch of, not helpful presets that are turning on parameters that aren't really in use at the time. Pro usage patterns is essentially some tips on how people mix their songs with something like a delay or a modulator. And test methodology is talking about how we intend to test it. What are the things we want to look for? There are areas we're concerned about. So dedicated presets scale through our LFO, scale through our delay times, look at how are we continually, doing runaway feedback exactly how we want, or is it starting to sound pretty bad? Things like that. And with this, we then would ask Claude to generate the preset. We'll get a Python script back. We'll run the script, and it will generate the presets for us. An important bit, though, for the plugin that I'm using, I use JSON-based presets, which are really helpful. You may consider doing that yourself. This is going to export everything into JSON. Now, we will, when we get to use the tools, convert the JSONs into VST parameters, so we actually are going to apply the right things. But for listening to them, you would need to do something like that. So just one caveat here. For the preset generation script, let me see if this is going to work. Oh, it is, good. So I have this code map, which is a nice little thing that Windsurf makes. Just to give you an idea of like what is it doing and how is it building these out, I'll just do kind of a little walkthrough here, though I'm not used to using the trackpad on this. And, oh, that's right. Sorry. So anyway, what it will essentially do is orchestrate kickoff setting up. And what this is, so in the talk, we're talking about making 100. This says 400 because it's kind of iterated quite a bit. So essentially these 3, 1E, 1D, 1C are essentially compiled all the preset different scripts into one. But as you can see, just to see how Claude approached it, it is realizing it needs to iterate on the different features of the product, which is going to feed into how it decides to fill out the JSONs. And then it finds specific areas that it is deciding are important. And you can see how it's taking, essentially, these are the presets it wants to make, and these are the parameters it's going to apply to it. So I know, like, that's the 256 bucket size, that's the 128, and giving us all the right values that we want there. So kind of interesting the way that it decided to deliver it to us, but really helpful in terms of showing the organization of that. And if I'm not happy with them, I'll go back, edit them myself, save them, and get them back set up. And I'll get full screen going the right way. That's available for you to check out as well. So we've got our presets. Let's move on to sonics. So for sonic testing, this is all going to be offline processing that we want to do. And the first thing we want to do is generate golden references, essentially capture what we think the right state is of the plugin. And then the other thing we'll use with DawDreamer is that we'll be capturing the plugin that's under test, which will be the plugin testing against itself, and then moving on to any changes we make to a new build. Python's going to orchestrate all the tests, speed them up because we want to make sure these are fast. We don't want to wait around for tests to have to finish up. So this will take a minute. And do all the audio analysis and phase cancellation, RMS, all the things that we're using to detect some sort of anomaly in the audio. And if we do have a failure, which in this case I'll show an example of a bug, we'll have Claude kind of pick through our failure, do a failure analysis, try to see if it can figure out where we might have gone wrong by analyzing the presets that failed. So first off, the thing you'll want to do is create your references. This will generate audio files and metadata, also JSON format. Because we had 100 presets, we're actually going to have 300 tests because we want to test mono in, mono out, mono in, stereo out, and stereo in, stereo out versions. Everything's going to get rendered to disk, and you'll run a script like this, which is essentially allowing us to also, which is very helpful, set up parallel workers and also make your computer fans turn on quite a bit. So we'll take a quick look at kind of what the logic is behind the creation. And this is, oh, sorry, because I don't have my notes. I'm missing a few things. But if you have non-deterministic elements in your plugin, let's say an LFO, a reverb that maybe randomizes some things, you will need to create a seed and either expose that as a parameter or find a way at build time to set that up, or any other way that makes sense to set that up. That essentially means that we want to deterministically set everything the same when we do the processing every single time. If not, you'll just get failures every time because your LFO is always starting at a new spot. Anywho, back to kind of the organization of what this looks like. It will, come on, there we go. Set up the script, parse what you ask it to do. I'll actually walk through so it runs through the code. Fixes up the seeds, because in case it doesn't do that, it at least makes sure. Sets it to 42, because why not? Pairs workers, and that's essentially going to start setting up a new worker for every single core instance you decided to allow it to. From there, it's going to figure out what the workers are, and then start to parse the preset sets out, and then run through its rendering. So here's your parameter mapping part down here, which will take the JSONs like I talked before, and then start to move those into values that we can then input past to DawDreamer and apply to the VST parameters. We'll then start to render each preset, loading the metadata, setting up the configuration. And the reason this goes so fast is because we set up one engine, set up the graph, we set up the plugin, and we don't actually tear the plugin down between each, which is actually kind of nice because it does give you some residual effect of like, am I leaving any crap behind from the last plugin preset that I loaded? But there are other ways that we can talk about doing this as well. But this will essentially start to burn through and render the audio, capture it, and export it into the proper folders. So now you have it in your golden audio test folder. Let's get back here. I think we're about to do one more. So once you've captured all of the presets that you wanted to into a folder, you have your goldens. And the first thing we want to do is test against our own plugin, making sure we don't already have some non-determinism we're not expecting. So with that, we'll then run our fast regression test, which is now going to spin up a bunch of workers to run the test and compare the audio against the newly rendered audio, or the second version, since we're doing a comparison test. So with that, and with this kind of a nice thing is we don't actually save any new audio to disk. We do it all in memory. We only would save off to disk if we had a failure, which makes sense because we don't want to take up a ton of disk space and deal with having to manage all of that. And similarly, we do the exact same bit, which is we set up the arguments. Can that even be read? It's just, okay, I'll figure it out. My Zoom is not working great. I'll just walk through it this way. Set up your engines, load all your plugins for mapping. We actually, one thing I didn't go over is the main preset does make a kind of a JSON file that tells us every preset that it's made. So again, that can load up by the log to anticipate all of the presets it's going to need to process within the system. We then set up our new preset renderer worker, which again sets up, goes and renders our new audio. And you can see kind of how that works. This is how you set it up in DawDreamer. This is instantiating the plugin. We're then going to apply the preset or load the signal test. This is create playback engine, playback. And that builds out the audio graph, so it sets up our input and outputs properly, renders out the audio, and then it'll extract the output so we can compare it back to the other block over here with our golden reference. If we do find a failure, we're going to save off that failure, including the failed audio file and the JSON results that were the delta difference, depending on any of the settings that we tested. And to go over what tests we are doing in this sonic test, and there may be a lot that you'll want to customize these. These actually have, as default, pretty aggressive phase cancellation rules. I think it's like -80. But do phase cancellation, RMS, spectral centroid, LFO correlation, and then it aggregates all that status together. All right. Cool. So with that, and this is again, because I had a lot more presets in my tests recently, you'll get a nice kind of output if everything goes well, telling you all the presets that were used, how many tests were run, and then it goes through and gives you kind of all of the pass-fail results of everything. And in this case, it was a pass. But oh yeah, and one thing that I think could be really cool with a test like this is to add potentially a few more features to it. And really leverage what DawDreamer can do. So randomizing the preset processing would be, I think, a pretty important thing. I do worry sometimes, you can get audio stuck in a buffer, and you want to make sure that that doesn't get caught. If we run the exact same sequence over and over again, we'll miss that completely. So doing kind of a shuffle with keeping a seed around so you can repeat that shuffle would be really good. Other kind of things that I think would be interesting, though I don't know if we would get much new results, is kind of going via hot or cold. So do we want to tear down the whole mixer and engine that we built out and then rebuild it up again for every preset? That would certainly do a good bit of stress testing on instantiation. But I think for me, I think the hot testing is actually probably a little bit more, kind of would render more bugs because you're really hammering on one plugin. Another great thing is DawDreamer does support automation. And since we can ask Claude to pick pairs of presets that actually are going to be able to smoothly automate between each other, so we're not going to need toggles, adjusters, stuff, you could start to put some pairs together and see if you can look for any automation glitches that might be in your, again, offline processing, but still it's good to check to see if you have any potential errors or smoothing, things like that. But one great thing is I did get a bug kind of early on with this. I'll just kind of walk you through what that looked like. So we discovered that we had a critical state leakage bug. We had 16% of our presets were failing, and it was kind of, weren't really sure what that was. So we looked at that. We had some of our phase cancellation was just a little below where our threshold was, so really probably couldn't hear it because everything else was still normal. So our RMS, our peak safety, were all within bounds. So kind of the fun thing to do is hand the failure folder over to Claude and say, hey, we've got some issues. What's the root cause looking like here? And I was able to look at all the presets, identify that all the ones that had the issue were actually driving the reverb above 0. So the issue would have been in the reverb plugin. And that there was something inside the code is called the diffusion system, which is actually where the bug was. And what we had done was we used a shared reverb algorithm that's used by another plugin. It has more features. It's a little bit more like in the early stages. And we had recently just feature toggled some of those features on. So they really weren't ready for prime time. And it did, though, find a issue in that algorithm. So instead of just turning the toggles off, we could actually just go and handle the fix for the filter states. And we were able to then pass our golden validation test after that, running the goldens yet again, updating them, and then doing another fast regression against those. So this is, of course, a lot of stuff dedicated to the areas that we wanted to test and the risk areas that we saw. But I think for any plugin you're working on, as you're growing, as you're starting to get more definition or you're solidifying what you want to see, this is a good way to scale up presets because it can take a long time to make on your own. And when you have something, I think, as potent as this that you can run, it feels a lot better to actually get it into your system. And really gets to kind of a simple flow, which is you capture your references, make changes, we test them, and do we get the expected result? And it's a good thing to remind us that expected results may be we made a new adjustment, a new feature. We changed how the feedback worked. We've changed, delay times. You actually want to run it and see the failures in the spots that you would expect. You should obviously go listen to your change. That's non-negotiable, but it's a nice thing to say, yep, that's what I was expecting. Let's do the update once you feel like you validated what you have. And now you're back to having a nice solid test you can run prior to checking in and finishing up that feature. And also, it's good to point out for like the thresholds of different tests, it's really going to have to be kind of be dialed in by you. You may have some levels of randomization you can't get away from. There may be, thresholds you want to actually focus on, not have them be so low. So anything that is here, obviously, we want to think about customizing it more for the product that we're making. So let's talk about performance. So performance, this means we want to know, is our plugin going to cause spikes while it's being used during playback? Do certain parameters have higher CPU? Maybe that's expected, maybe it isn't. Maybe you just don't know and you want to be able to get a nice heat map of what that's looking like. What our worst case preset setting is, and we can even see if our latest changes made it better or worse than we were expecting. Maybe trying to do optimizations, and now we have a nice pairing of sonics and performance to see if we're going in the right direction. And if our changes want to be accepted. Maybe we don't phase cancel as much, but we're getting way better performance. Another good reason to update. And surprise CPU usage, which, if you're testing a plugin and your main thing is let me do a quick smoke test in one DAW with one instance, sometimes that stuff gets masked pretty quickly, or you have a few issues over time that start to add up and you realize, oh, this is a kind of a culmination of new things we added. So we have our presets, that's great. We're going to use the exact same ones. It's another good reason to kind of keep making that more robust over time. And let's talk about the plugin perf app. So it's a very alpha command line tool based off of Juice that will load up a plugin, run it. It actually tries to run it in a real-time thread worker, kind of just like you would see in a DAW. Probably seems starting to get that pretty stable, but still working through any kinks on that. But the good thing is we are getting consistent results. So you're able to pick your plugin, take a folder full of presets if you want. What's your output file? So this will be a CSV file you get with all of your results data. What buffers do you want to have? So you could enumerate, I want to have 32 through 1024 on the powers that we would normally use. Iterations, so do we want to run 10? Do you want to run 10,000? This is of the buffer size running over and over again. Larger the sample, longer the time, but also larger the sample, you're going to get to see if you're getting more jitter or deviation from your standard expected usage. Warm-up time just keeps some of the first couple calls out, so it lets it kind of stabilize, and sample rate, and like I said, buffer sizes as well you get to work through. So you run through it, this is what it would look like if you ran it. The command line, it's horribly exciting. But the nice thing is it does kind of also start to track things like the computer sample rates and other things that you run, because I think this can grow into kind of a bigger tool over time that could potentially, do some more clever things. And in the upper right-hand corner, you can click and go download it and build it and see what you think. And this is an example of the results CSV. I actually narrowed up, there's a bunch of other analysis that I hid, essentially, doing some statistics. But the main two things, like for me, that I really want to worry about is how is my CPU percentage? This is the percent of time it took on the core that had to get things finished, and what's the variance? And kind of a cool bug we see here is BBD is a bucket brigade and CCD is a different type of device for storing the delay. And this model is way more CPU has way more CPU usage, and it also has more variety. So there's probably something to look into on that issue. So this is kind of nice things to find and how you might want to use this data. Also keep it around, see how this is changing over time. I spend a lot of time kind of running the same tests over and over again to see if I'm able to lock in similar results. So far, it's been pretty good, but I've really only done it on my computer. Oh, and it's Mac only, so just realized that. Anywho, so with the results, kind of the main thing we can do is, of course, get a basic run. We can do an extensive run. We can go through all the presets. And another really nice thing, which I think is important for if you've ever had to have the conversation, if a product manager is like, well, how many instances do I need? It's like, I don't know, what computer do you have? I can't tell you that. It does let you look at you can go through your own plugin folder, look at how your plugin stands out against others. And so if you're doing competitive analysis in the market, where do you stand? Do you want to get more efficient, or you actually, maybe you do need to run more CPU, your heavier process? It's another nice tool to have to get quick validation of where you are kind of in space and time with your product. And future iterations, I think this could be nice to kind of potentially start to keep a server. Like you could ask your customers, if they're running into an issue, well, why don't you run these results, see if we're seeing something, the same that we're seeing in other places. I don't know if we'd really, you could find some way to run those tests, but especially across any of your test beds that you have, just looking at how things can be consistent. I don't think this is very helpful in, trying to put it in GitHub Actions or anything, because you'd run a bunch of CPU cycles you don't need to. And I don't know that you'd be able to have that same level of determinism, hence keeping the tag of like what computer was used on it, what OS, things like that. So if those change, you get a new OS update, you can potentially see how that impacts your product. And we want to cross-reference this with analytics. Let's say you integrate Sentry into your system, you're going to start to see different computers that are getting used with your product, and then you can start to see if someone's having performance issues, if you do anything like that. See if you can reference any testing you've done internally to see if, you have an issue and something you might want to look at. And really, that's the end. Hope you enjoyed that, and if you have any questions, let me know.